Hi guys, welcome to class today. The last class I introduced you to what vectors are and I explained the dimensions of vector. So today we'll be starting with a new episode which is the basic operations on vector. Basic operations. Basic operations on vectors. Now we'll be starting by how do we add and subtract vectors via their components. Now, or dimensions. So the first one, let's start with addition of vectors. Addition. Now, let me explain by an example, by an illustration. For instance, let vector A be AI plus BJ plus CK. And you have another vector, let's call that vector B, right? And vector B in it is, let's say, xi plus yj plus zk. And the question asks you to add vector A plus vector B. Now, the simple thing you have to do is that when you want to add or subtract vectors, are you with me? When you want to add or subtract vectors, you add vectors having the same component. Like this, don't forget I represent the x, y, this j represents the y, and k represents the z component. That implies that if I'm to add this, I will add those that have the same component together. Are you with me? That is, I had I with I had j with j, and k with k. That implies that for me to add vector A and vector B, this is the coefficient of I in A. This is the coefficient of I in B. That makes A the coefficient. I add up their coefficients, I plus, then I move to J, which is B plus J. That's for J, plus that's C plus Z. That is for the component K. If you had noticed what I've done, I really added components like components is much better than dimension. This is a 3-dimension, this is a 3-dimension. So I had this component together. This JJ, I had them. This is K and K, I added them. The same thing applies when you are set to find the subtraction. Now, that implies that if it is subtraction, A minus B, that will be A, you have to subtract their coefficient and add their vector component plus the other one, B plus B minus, we're subtracting, right? Minus, then plus C minus Z. So this is the law guiding addition and subtraction. So I'll combine the two together. So this is the law guiding addition and subtraction of vectors. Now, let's pick up examples where we are said to add or subtract some certain set of vectors. Now, example. Vector A is given as 2i plus 3j minus k, and vector B is given minus I plus 4j plus 2k. The question number 1 says A plus B. Now, solution is as simple as what? As ABC. So what do we do? Vector A plus vector B. So what's vector A? Vector A contains 2i plus 3j minus k plus B, which is minus I plus 4j plus 2k. Now, from the first illustration that I explained on how to add and subtract, I told you that you are to add up components together. So that means for I, we have 2 here and you have minus 1. Don't forget this is minus 1. That becomes 2 plus minus 1. That is for I. Plus, now let's move to J. this is 3 plus 3, and we are adding plus what? So that is 3 plus 4. J. Here you have minus 1 plus 2, and that is for the K component. And going by that, 2 plus minus 1 simply means 2, this is just 2 minus 1, isn't it? Because plus times minus. So here becomes 2 minus 1, that is 1i. So you can just write that as I, representing 1i. Are you with me? Now 3 plus 4 here gives what? Gives 7. That means you have plus 7j. 1 plus 2 minus 1 plus 2, that becomes 1, that is plus k. And this is vector A plus vector B. This is how we add that up. So we just add like components together. Now, alternatively, you can do it this way. Now, since you've gotten this, you can also expand the bracket. So this becomes 2i plus 3j minus k. This becomes minus I, right? Plus 4j plus 2k. Then you collect like them. That is I with I, j with j, and k with k. That is 2i minus I plus 3j plus 4j minus k plus 2k. Now, 2 minus 1, that is 1. So that's how I would add, which is just the same as the previous one. So 3 plus this becomes 7j, because these are the same component, and minus 1 plus 2 becomes 1. So don't forget that all this has 1, but in mathematics, automatically when you have variable like this, has a coefficient of 1. So this is how we go about the addition of vectors. Now that we've gotten that, let's attempt example 2. So the second says vector A minus vector B. And vector A is 2i plus 3j minus k minus I plus 4j plus 2k. Now let's expand. So that means we have 2i plus 3j minus k. Minus times minus becomes plus I minus 4j, because plus times minus is minus. Minus times this becomes minus 2k. Now that we have this, we can now collect what? Like components together. So that means we have 2i plus I plus 3j minus 4j minus k, right? We have minus k, then we have what? Minus 2k. Now, when we add up this, it becomes what? 3i, right? Now, 3 minus 4 becomes minus 1, which is minus j. Don't forget 1 is there. Then minus k minus 2, that's minus 1 minus 2 becomes minus what? 3k. So this is how we what? We add and subtract vectors based on their component. Is that clear? So this is how we add and subtract vectors. Now let's pick up another example so we could understand in detail how we subtract and add up vectors. Example 2. Now proceeding with our example under addition and subtraction. Oh, this is minus. Now the question says that if vector, now this is another way of representing the vector by using a cap head for each vectors. Now the question says that given that vector L is this, vector M is this, and vector N is this, the question says we should find L plus M minus N. Now how do we do this? It's as simple as we've done the previous. Now vector L plus vector M plus vector N becomes, now we have L to be I minus 3j plus 7k, right? My plus m. M is 4i, right? Plus j minus 6k minus n. Oh, this is a minus rather. Minus n. And n is given. This is also a three-dimensional vector. I explained that in the previous video, so you can check that and understand why it is called a three-dimensional vector. Now, since we have this, what we have to do is to expand the bracket. So this we have I minus 3j, right? Plus 7k. Everything becomes the same because we are multiplying by a positive sign. So plus 4i, right? Plus j plus minus 6k rather, right? Then minus times minus becomes plus I. Then we have minus 2k. Now that we have this, what we have to do is to collect like terms or like components. So we have I here, we have I here, and we have I. So let's bring them together. That is I plus 4i, right? Plus I. So we are done with families of I. Now let's move to j. So we have minus 3j plus j. That's all. We don't have any other j again. Can you see? Now the next is k. That is plus 7k, right? Minus 6k, then minus 2k. Now since we've collected all the like components together, then we can proceed with adding and subtracting. So this is 1 plus 4 plus 1. 1 plus 4, 5 plus 1 becomes 6i. Sorry, it becomes 6i, right? Now this is minus 3. This is, we just have two components of j's, right? So minus 3 plus 1, that becomes minus 2. That's minus 2j. Now 7 minus 6 is 1. Minus 2, that becomes minus k. That's minus 1. So this is our final answer when we add L and M and subtract N. So this is the resulting answer. Hope you understand. And that is how we add and subtract vectors with the form I, jk component. Is that clear now? So it's as simple as that. If you actually like the video, please click the subscribe button to follow us up more for more updates on MTS 104. Thank you for watching.